In this topic, you will learn about the concept of mixing coagulants and flocculants and the steps to perform a jar test. With the help of this information, you will be able to suggest suitable mixing solutions to your customers and evaluate the mixing conditions in the plant. After completing this topic, you will be able to sequence the steps to perform a jar test. Mixing is an important operation in the coagulation and flocculation processes, which directly affect the treatment performance. Initial mixing intensity is critical to accomplish optimum polymer dispersion and polymer to particle contact. Coagulation and flocculation are done under different mixing conditions. During coagulation, fast mixing is required for coagulant distribution. This is because turbulence created in the mixing operation increases the polymer to particle contact. In the case of flocculation, slow and gentle mixing is required to encourage particle to particle contact. If the mixing during flocculation is too fast, the aggregates that are already formed will break up. Mixing energy is expressed in velocity gradient and the unit is per second. The mixing speed of the jar test is expressed in RPM or revolutions per minute. The mixing energy varies for coagulants and flocculants. The appropriate mixing energy of inorganic coagulants is 200 to 300 per second of velocity gradient. For organic coagulants it is 300 to 400 per second of velocity gradient, and for flocculants it is 60 to 90 per second of velocity gradient. The jar test is a standard laboratory simulation for wastewater treatment and influent clarification. Jar test is used to determine the optimum chemical program, establish the best order of chemical addition, establish the approximate chemical dosage, and it is also to determine the best equipment operations, such as the most effective mix cycle for a given chemical program. While performing a jar test, ensure that wastewater samples used in the jar test are representative or untreated samples. Hence, the water samples should be collected from the upstream of the chemical injection point. In addition, ensure that you vary only one parameter at a time while testing. You should not vary the chemical and mixing rate at the same time. You should simulate the same mixing sequence in the plant. In other words, if the polymer is first mixed to a certain length of piping, and then through a mixing tank, and thereafter further mixed through another length of piping, then you should determine the mixing energy in each of these three mixing modes separately, and follow that same sequence in the jar testing. Jar testing may be used to evaluate the effects of changes in chemical doses and points of application, choosing alternative coagulants, adding polymeric coagulant aids, implementing alternative preoxidation strategies, varying mixing intensities and times, and changing overflow rates on the removal of particles, natural organic matter, or other water quality parameters of concern. The key parameters include velocity gradient or mixing intensity in the rapid mix and flocculation basins, effective retention times in the rapid mix and flocculation basins, surface loading rate of the sedimentation basin, and actual retention time in basins if jar testing is being done to evaluate time-dependent reactions for which full-scale reaction time influences results. The jar test helps you determine the flocculants that can be used under specific conditions. For this flocculant jar test, you need to first fill a jar with a fresh sample of water and then mix rapidly at a speed that duplicates plant conditions. After that, you may need to chlorinate the water if this is practiced in the plant. This is an optional step and is based on the plant's operating conditions. Next, you need to measure the water pH with a pH probe while the mixer is still running. If necessary, you may need to adjust the water pH with drops of acid or caustic to the actual plant pH or to the desired pH level. This pH adjustment is needed if there are pH adjustments at the plant and your water sample is collected from the upstream. In jar tests for investigating the impact of various pH, this is especially important. Some inorganic coagulants can lower the water pH significantly. In such cases, the water pH should be adjusted higher such that the final pH will fall within the desired range after coagulant addition. For practical purposes, the amount of caustic agent needed for pH adjustment can be predetermined by separate titration test with coagulant added. Now add the coagulant to the jar at the desired dosage. The coagulant should be pre-diluted to the same strength as practiced in the plant or to a strength if you would like to investigate its impact on the treatment performance. Now the mixing of the coagulant starts. Keep the mixing running at the original high speed for the duration that simulates the mixing of the coagulants in the plant. At this stage, tiny pin flock should start to form if the coagulant is effective. After the mixer has run at a high speed for the required duration of time, reduce the agitator speed to 40 to 50 rpm and add the flocculant. The flocculants should be pre-diluted to the same strength as practiced in the plant or to a strength you would like to investigate its impact on the treatment performance. After you have added the flocculant, immediately reduce the speed and run for duration that simulates the mixing of the flocculants in the plant. This is usually 20 to 30 rpm for 5 to 10 minutes. During this stage, if the flocculants work effectively, you should see flocks starting to grow in size. Stop the mixer and record the flock size and settling rate for each jar. The flock size is normally recorded as a comparative scale of 1 to 5, with 1 being the worst and 5 being the best. After 5 to 10 minutes, draw some water from the bulk and measure the supernatant turbidity. This process is normally carried out in 4 to 6 jars in parallel at the same time. Test different flocculants first to select the most effective one. After the most effective flocculant is selected, vary its dosage to determine the minimum dosage requirement. You may also evaluate combinations of different amounts of coagulants and flocculants to determine the most economical combination. In these tests, you may want to add the present planned treatment amounts to establish the first jar as a control sample. Other studies with jar tests may also be carried out to assess the impact of different pH, different mixing energy, or different temperatures on the treatment performance. Remember that you should only vary one parameter at a time. This completes the topic of mixing and jar testing. Here is the summary of the key points. We now have reached the end of mixing and jar testing topic in the wastewater treatment series. Thank you for listening and watching this lecture. If you would like to see other courses, please visit watertreatment.training.